So let's see if we can hack this thing, right? This is a cylinder with a radius. This is the famous hydrometer problem, right? Hydrometer is like a thing that you sink into a fluid, and how far it sinks in tells you the density, right? Okay, and these are really pretty simple. This distance that it's submerged, right? I'll call that x submerged, right? Is to the length. So here's our length. Right, we can just set up a simple proportion. So x submerged is to the length as the density of the object is to the density of the fluid. Okay, and this makes sense, right? If it's half submerged, then it's half the density of the fluid. If it's 1/4 submerged, it's 1/4 the density. If it's all of it submerges, as long as it doesn't sink, then it's the same density as the fluid, right? Okay. So let's see. We have the length, right? This is 0.25, right? We're trying to figure out the amount that's submerged. We have the density of the fluid is 865, right? We got to figure out the density of the object, though. Okay, so let's do that first. The density of the object is mass over volume. So that's, let's see, here's our mass. So 0.0375 kilograms. And then it is a right circular cylinder, so its density is going to, or sorry, its volume is going to be pi r squared h, right? So divided by pi, the radius is small, right? 0.0092 squared, right? And then h is 0.25. All right, here we go. So I need to square that. All right, I think I've got it here. Okay, so this density is actually 564.11. And now we're ready to go, right? We can go, the distance submerged, right, is to 25 centimeters, right? That equals 564.11 divided by 865. All right, let's do this. Okay, so 25 times the number I just got divided by 865. Let's see if I get the same answer. 16.303. X sub is 16.303 centimeters. Ta-da! I don't know if that's easier than the other way, but you know, I can think of 3 different ways to do this. So, yeah, there you go. If you come up with an easier way, show me.